Today, we are diving deep into a technology that didn't just move the goalposts for AI vision, it completely changed the game. We're talking about the vision transformer. It's this wild idea that took a model designed to understand language and, believe it or not, taught it how to see.
And that question right there, that's the key to this whole revolution. See, before vision transformers, or VITs as we'll call them, the world of AI language and AI vision, they were basically separate universes. They used different tools, different philosophies. But the big what if was, what if they didn't have to be? To really get why the VIT was such a bombshell, you first have to understand the battlefield it stormed into. For years and years, computer vision was a kingdom, and it was ruled by one very powerful, very dominant monarch. And this model was so good, so utterly dominant, that it just became the go-to, the default architecture for pretty much any image task you can imagine. We're talking everything from finding cat pictures on the internet to being the eyes for early self-driving cars. And here he is, the king, the convolutional neural network, or CNN. For the better part of a decade, if you were doing anything serious in computer vision, you were using a CNN, period.
So the secret sauce for a CNN is its inductive bias. Now, that's just a fancy way of saying it has a built-in assumption about how the world works. And the CNN's big assumption is that what's important in a picture is local. It scans an image with these tiny little windows, these filters, hunting for simple stuff like edges, corners, and textures. It literally sees a cat's whisker before it ever figures out it's looking at a cat. Now, this makes it super data efficient, but it also really limits its perspective.
But then, in 2020, a challenger shows up, and it comes from a totally different world. Natural language processing. This new kid on the block was based on the transformer architecture. Yeah, the very same tech that powers models like GPT. And it had a completely, radically different way of seeing things. And just look at this timeline. It shows you how incredibly fast this all happened. The original transformer paper for language drops in 2017. A mere 3 years later, researchers figure out how to adapt it for vision. And by 2021, the vision transformer is already beating the best CNNs on major tests. The king? Well, the king was officially on notice.
This quote, this is the title of that groundbreaking VIT paper. And it's the secret to the entire thing. It's such a simple, elegant, and unbelievably powerful idea. What if you could just treat an image like a sentence?
So here's the magic. A VIT doesn't scan for little local features. No, it just takes an image and chops it up into a grid of patches, let's say 16 by 16 pixels each. Then it treats that sequence of patches exactly like a sentence of words. It uses this incredibly powerful mechanism called self-attention to look at all the patches at the exact same time, and it figures out how important each one is to every other patch. It's all about how they relate to each other to make the whole picture.
And this just nails the core difference, doesn't it? A CNN builds its understanding from the tiny details up to the big picture. But a VIT, it starts with a global view from the get-go. It's immediately asking, okay, how does this patch of an ear relate to that patch of a tail, and how do they both relate to that patch of the rug the cat is sitting on? It gets the context from the very beginning.
So when you put them head-to-head, you really see the trade-offs. The VIT's global worldview is its absolute superpower, right? It lets it understand these long-range relationships in an image that a CNN might just completely miss. But, and this was a huge but, that power came at a steep price. VITs were incredibly, ridiculously data hungry. They needed to see massive, massive data sets to learn effectively, way more than CNNs ever did. The original VIT, it was an amazing proof of concept, but those weaknesses, they actually sparked this incredible explosion of creativity. Researchers started building a whole family of new and improved transformer models for vision, and each one was designed to tackle a specific problem. This was the #1 hurdle. I mean, if VITs could only be trained by giant companies with access to billions of images, how useful could they really be? So the big question became, how do we get these things to learn more efficiently? Okay, one of the most brilliant solutions was the masked autoencoder, or MAE. Basically, it learns by playing a game with itself. It takes a picture, hides, get this, up to 75% of the image patches, and then its only job is to reconstruct what's missing. By doing this again and again on millions of unlabeled images, the model learns these incredibly rich, robust features about what the world looks like, all without needing a single human label. Another super clever trick is Dino. This one uses a teacher-student setup.
You have a student model that learns by trying to perfectly match the output of a teacher model. And the trick is, the teacher is just a more stable, averaged out version of the student itself. This whole self-distillation process forces the model to learn really consistent and useful features. And again, it does it all without needing any labels.
Now, the other massive headache was the sheer computational cost. That self-attention thing, where every patch is compared to every other patch, well, the cost of that goes up quadratically as the image gets bigger. It just made VITs really slow and a total pain to scale up.
The Swin transformer was the answer. It tackled this problem head-on by kind of cleverly bringing a little bit of the CNN's local first thinking back into the mix. It does its attention thing within smaller windows of the image, and then it cleverly shifts those windows around and merges all the information. What you get is the best of both worlds, the efficiency of local processing with the power of a global, hierarchical view. And it's this kind of smart engineering that really unlocked these models for all sorts of real-world uses. So thanks to all these amazing innovations, vision transformers aren't just some experiment in a research lab anymore. No way. They are now the very backbone of some of the most advanced AI vision systems on the entire planet. The impact is just staggering. Seriously, look at this list. From self-driving cars that absolutely need that global understanding of a chaotic street scene, to medical AI that can analyze the full context of an X-ray, all the way to those generative models like DALL-E that literally create art from text. Yeah, vision transformers are at the heart of it all.
And they are scaling to just astronomical sizes. A state-of-the-art VIT built for predicting weather and climate has 113 billion parameters. That's the kind of massive, truly global thinking these models make possible. In this case, for understanding our entire planet.
Which brings us to a final, really big thought. This whole shift, from seeing images as just grids of pixels to seeing them as sentences made of patches, it's more than just a technical tweak. It's a fundamental leap in how we think about vision. It's opening up a future where AI doesn't just recognize objects in a photo, but maybe, just maybe, it can understand the relationships, the context, and even the stories hidden inside that image. The book on AI vision has been completely torn up and rewritten from scratch.